Hello geometry scholars, today we're going to be continuing our work with trigonometry by looking at the law of sines and the law of cosines. Now as per usual, please make sure you have your notes or at least a blank sheet of paper to write on, something to write with, and a calculator. Again, a calculator is going to be extremely useful in solving the problems in this unit. So let's get into the law of sines and cosines. Now we start with a question here. How do you find the sides and angles of an oblique triangle? So what is an oblique triangle? An oblique triangle is actually a triangle that has no right angles. We've spent the last few units learning how to solve right triangles. We looked at special right triangles, 45, 45, 90, 30, 60, 90. We looked at sine, cosine, and tangent. If we didn't have a special right triangle, we could apply sine, cosine, and tangent. Or we could apply their inverses. But all of those rules only worked when there was a right angle in the triangle. So what do we do if there is no right angle? Well, this is where the law of sines and the law of cosines come into play. The law of sines is actually a proportion. We're going to look at the angle and the side. So the small letters, little a, little b, and little c, represent the sides of the triangle. And those sides are going to be compared with the angles opposite them. So side A compares to sine of angle A. Again, notice the side and the angle are opposite each other in the triangle. Side B compares to sine of angle B. Again, the side and the angle are opposite each other in the triangle. And side C compares to sine of angle C. Now, since these are individually ratios, we've learned at the beginning of our last chapter that the ratio can be flipped. As long as we flip it for all of the parts, we still get an equivalent proportion. So these are actually the same equation. It really doesn't matter whether you put the sign on the bottom or the sign on the top, as long as the side and angle that are opposite each other are the ones that are compared within each ratio. The next law is our law of cosines. This one has three variations, but they're really following the same pattern. So once you get the pattern down, you'll be able to use any one of these three equations fairly easily. So our first equation, we'll look at that. A squared equals b squared plus c squared, so very similar to our Pythagorean theorem, minus 2 times bc times cosine of A. Notice that the ends of this formula are a side and an angle that are opposite each other in the triangle. That holds true for every one of these others. We start and end with B. We start and end with C. So whatever letter you start with, you need to end with that same letter. In the middle, we have the other two sides. Notice there are no more angles in here. These are all the little letters. So we've got a b squared and a b, a c squared, and a c. And again, that pattern is going to follow suit in the other equations. We begin and end with the same letter, whereas the other two letters are in the middle of the formula. Begin and end with the same letter, c, so that leaves a and b for the inner part of the formula. Now let's see how we can put these to practice. We have these two rules. We need to know when they are applicable. Not every triangle will use both of these rules. So we have a nice little chart explaining to us when to use which triangle. The law that is used is going to be determined by the information that is given. If the problem gives us two angles and a side, whether the order is AAS or ASA. So if we sketch out our triangle and we see we are given two sides and an angle in any order, we're going to utilize the law of sines. Now, if we are given two sides and the non-included angle, here's that donkey case, SSA. Now, there is no donkey postulate for congruence, but we do actually have a donkey rule for our law of sines. If we have two sides followed by an angle, we will actually use the law of sines to solve. Now, this is actually a very special case. It's called the ambiguous case. Now, when something is ambiguous, it's unclear, it's uncertain. There are multiple possibilities. So in this ambiguous case, we could actually have a couple different possibilities for what kind of triangle we have, whether it's one solution, two solutions, or none at all. And we will look more at this case in the next video. Case number 3, SSS. So if we're given 3 side lengths, we're going to utilize the law of cosines. And the last possibility, if we're given 2 sides and the included angle. So if that angle is in between the sides we're given, we're going to use the law of cosines. So let's go ahead and try a couple of problems. First one, we have the diagram below here. Notice we are given 2 angles and a side. So right away, 2 angles and a side in any order. This particular order is AAS. We're going to use law of sines to solve. So this is going to be a law of sines problem. So it says that in the diagram we want to find the distance each person lives from the school. So we've got Jimmy and Adolf. Jimmy lives X units away. Adolf lives Y units away. We want to figure out how far each one is individually. So to utilize our law of sines, we can use the angle 102 and the side opposite 3 miles and create a sine ratio. So the side length 3 compared to the sine of the angle 102. There is our first ratio. This is going to equal, let's use x and the 17. These are opposite each other. So the side length x divided by the sine of 17 degrees. I'm going to solve for x by solving the proportion. I can multiply by sine of 17 on both sides. That way multiplying and dividing by sine of 17 cancels. And we're left with 3 times sine of 17 degrees divided by sine of 102 degrees to get our x value. So let's pick up our calculator and see what we get. 3 times sine of 17 divided by sine of 102. So x should be about 0.9. About 0.9 here for our x value. And our unit is miles. Take a minute, folks, pause the video, see if you can find the side length for y. Now a quick hint, you're going to need this angle down here in order to do so. So pause the video, use the law of sines rule, and see if you can find y. Alright folks, now that you've had a minute to try it, let's see how you did. We're going to use, again, that same original sine ratio, 3 compared to sine of 102 degrees is equal to the length y over sine of our angle. Now to find our angle, we know there's 180 degrees in a triangle, so I'm just going to subtract from 180 the 2 angles we already know. So our missing angle should be 61. So I'll use sine of 61 degrees. I'll multiply the sine of 61 to the other side. And I'll use this value to solve my equation. So 3 sine of 61 divided by sine of 102. Y should be about 2.7 miles. Let's look at the next example. Here we're given a triangle. We are told that side D is 19 inches. Now remember, side D, little d, has to be opposite angle D. So I'm going to draw my side of 9 down below. Side E is 12 inches. Again, side E has to be opposite angle E. So I'll put my 12 here. Finally, angle F is 46 degrees. We want to find side F to the nearest hundredth. Now first I need to know, is this a law of sines or a law of cosines problem? I am given a side, an angle, and a side. Looking back at my chart, An SAS triangle is a law of cosines problem. So we'll utilize the law of cosines. A squared equals b squared plus c squared minus 2bc times the cosine of angle A. Now again, A, B, and C are just variables. So we just need to plug in our values where they belong in the formula. So even though this is angle F, it's our angle measure in the formula. Even though this is side F, it is the side that's opposite the angle in the formula. So I'm going to fill those in as f squared and cosine of 46. Again, the beginning and the end of the formula should be the opposite side and angle. The remaining two sides fill out the rest of the formula. So I'll say b is 12 and c is 9. So now, to find our value for f, we would need to solve this equation. Now be careful when you do so. We can say 12 squared is 144, 9 squared is 81, and we can multiply those together. 2 times 12 times 9, and we'll get 216. But as you simplify, remember that multiplication, 216 times our cosine, is a rule that would come before addition or subtraction. So while I can add the 144 with the 81, I cannot now subtract the 216 because I have to multiply that 216 by the cosine of 46 before I can do any subtraction. So let's do that. So I get about 75 on this side of the equation. But we're not quite done. Remember, our equation was solving for f squared. So in order to solve for f, I've got to square root both sides of the equation. So side f should be about 8.66, nearest hundredths for this problem. Folks, pause the video and try number 3. Draw your triangle, decide, do you have a law of sines or a law of cosines problem? Once you've decided, solve and see what you get. Alright guys, now that you've had a minute to give it a try, let's see how you did. Again, I'm going to sketch my triangle so I know what case I have. Side F, side E, and side D. This is an SSS problem. And an SSS problem is a law of cosines. I want to find large F, which is my angle. So I'm going to use angle F and side F as the ends of my formula. So 12 squared equals the other two sides, 10 squared and 18 squared, minus those two sides times 2, times the cosine of the angle opposite the side on the other side of the formula. So these are both f's. Again, I can work through and solve. Oops. 100, 324. And I'll continue to solve by combining like terms. Again, remember these two can combine, but I cannot combine it with the 360 because the 360 is multiplied by cosine of f, and multiplication has to be applied before we can do a subtraction. Now this problem is a little bit different than the last one in that we need to solve for the angle. So we want to get angle f by itself, meaning I need to move everything else to the other side. So I can subtract the 424, and I will divide by the negative 360. Now, once again, remember your rules from last unit. In order to solve for an angle, we need to utilize the inverse of our trigonometric function. So I'm going to use the inverse cosine to cancel out with the cosine and find our value for f. So this is what I can plug into my calculator. Inverse cosine of negative 280 divided by negative 360. And I'll find angle F to be about 38.9 degrees. Last two questions here. Summing this up, when do we use law of sines and when do we use law of cosines? Pause the video, write it down. Alright guys, sines, hopefully you answered as AAS triangles, ASA triangles, and SSA triangles. Law of cosines, hopefully you answered SSS triangles and SAS triangles. Alright folks, that takes care of our video for today on law of sines and law of cosines.